So, we have seen how the images are formed using concave mirror as well as convex mirror using ray diagrams. So, we know where the object is kept, we draw the rays following all the standard rules, then we get an image. But it is not possible every time to draw a ray diagram just to know where the image is going to be, isn't it? I mean, that is a very cumbersome method to draw a ray diagram for every time some object is kept. You have to draw to the scale, and then you have to draw everything to the scale, the height, and then you have to get the image and then get the answer, oh, this is where the image is going to be. Now, that is not the proper method. That just gives a fair idea where the image should be. It may also give you exactly, but then for getting the exact answer of image height and image distance, it is not the proper method of always drawing the ray diagram. So, for that what we use as a mirror formula. I am just going to write the formula, we are not here to going to derive it and all that. So, that is not part of the portion for us in the school level, not for class 10th. So, just a mirror formula will be written, we will learn how to use the mirror formula to do various calculations. Now, I will write it and then I will tell you what it is. 1 by V plus 1 by U is equal to 1 by F. What are these distances? Of course, F looks very simple. Directly we know F is equal to focal length of mirror. Okay. U is the object distance. So, U is equal to object distance. So, it depends upon, after all, there are 1, 2 and 3 variables are there. So, if we know 2, we will be able to find the third one. So, among these 3, if any 2 is given, the third one can be found by just directly substituting and get the answer. So, naturally we must know what is given and what we have to find. So, if object distance is given, that is where the object is kept, if that is given, that means U is given. So, this is known as object distance. Then V obviously has got to be image distance. So, 1 by V plus 1 by U is equal to 1 by F is the mirror formula for concave as well as convex mirror. In fact, the same formula we can use to find for the plane mirror also, that we will come to that later. Okay. For a plane mirror, there is one thing very well known to us, U is always equal to V. Wherever you keep the object, the same distance the image is formed behind the mirror. We know that very well for a plane mirror. So, U is equal to V. So, with that we will find out that what is the value of F. We will come to that later, but this is for any other spherical mirror like concave as well as convex mirror. This is the standard formula. Now, apart from where you find the object as well as where you keep the object and where you get the image, we also have to know the size of the image. So, we will learn what is known as magnification, that is how high the image is formed. The image may be smaller than the object, the image may be larger. We have seen in concave mirror, we have drawn the ray diagrams to know that. The image may be of the same size, the image may be upside down or erect. There are so many times, isn't it? So, magnification is given by height of image by height of object. Obviously, if this is in centimeter, this also is going to be centimeter or either way. So, both will be either measured in centimeters or both will be in meters. Of course, we are not going to have meter long objects, but whatever the object unit is there, the same will be the height of the image in the same units. So, since this is just a ratio, magnification has no units. So, it is just like 2 times, 3 times, 4 times, the image is 5 times the size of the object, the image is half the size of the object, like that it will come. The formula for this is minus of V by U. Even if you know V and U, you can find the value of magnification. Even if you do not know the size of the object, you can tell that much, that object is going to be magnified or diminished, so many times it is going to be big, so many times it is going to be smaller. That thing you can tell here easily by using this formula minus of V by U. Now, just for example, suppose after substituting anything, we are going to come to that, but I am just directly coming to the final point. Suppose I get this value of magnification after putting everything as with a minus sign 0.25. So, it is either 0.25 or I can even write it as minus of 1 by 4, both are okay. So, either if I write it in fraction, I write as 1 by 4, or decimal I can write like this, no problem. If this is the answer I am going to get after doing all this substitution, what do I understand by this number? This number has got this magnification, it has got 2 things. One is a sign and one is a number. This is the sign and this is the number. Now, depending upon the sign and the number, we can immediately tell what it means. A negative sign means the object is straight but the image is upside down. That is why it is negative. We saw some time back, if this is positive, this is negative, the image was negative, isn't it? So, a minus sign means image is inverted, and inverted images are always real. It is a real, they go together, real and inverted, that is how we call it. So, when the sign is negative, so you look at the sign, you can immediately come to the conclusion that the image is going to be real and inverted. That is number one thing. Now, look at the number. So, first we will see the sign and then the number. How is the number? Is it less than 1 or more than 1? If it is going to be less than 1, which is here, 0.25 is less than 1, then if it is less than 1, what does that mean? Diminished. That is, it is not only real and inverted, it is also smaller, the image is smaller than the object size. So, looking at these two, we can immediately come to other conclusion also. So, if the sign is going to be positive, what does that mean? Image is not real and inverted, but it is virtual and erect. So, an erect image is always having a magnification of positive, and inverted image is magnification negative. So, with this sign we can find. Similarly, less than 1, it is diminished, more than 1, it is enlarged. If the magnification is more than 1, if it says 2, if I get an answer here as minus 2, this is the answer I am getting. So, what does that mean? Minus sign will tell me it is image is real and inverted, but this number 2, it is more than 1, that means the image is enlarged. You have a bigger image compared to the size of the object. So, look at the number, look at the final answer of your magnification. This answer is enough to give you the nature of the image. Divide it into two portions. Look at the sign, look at the number. Sign will tell you whether it is real or inverted or virtual erect. The number itself will give you whether it is smaller or bigger as far as the image is concerned. So, more than 1, it is enlarged, less than 1, it is diminished, and if it is equal to 1, that means image size is the same as the object size that you have seen in concave mirror. When the object was kept at C, the image was also of the same size, in which case of the same size, that is this was 1, but the sign was minus. What does that mean? That the image is inverted and real, but of the same size. So, please divide this entire thing into two portions, sign and number. The sign will tell you something, the number will tell you something. After doing this, you can always mentally, or for that matter for some time, draw a ray diagram to confirm whether this answer agrees with what we have done in the ray diagram. This is just for initial some problems when you do, so that you are sure what you are doing is correct, because these things are very, very important. Okay, now since this is the formula, two more things are extremely important. Now, focal length of a mirror is constant. So, focal length will be given. Okay. Now, we must know whether focal length is positive or negative. Unless we know, we cannot substitute anything else. Suppose I want to find V and it have been given U, that is object distance is given and focal length is given. I want to find the image distance. Object distance, since I just now told you, it is always on the left of the mirror, it is always negative. So, if the question says the object is kept at a distance of 10 centimeters, in the formula you will put immediately as minus 10. For object distance, it is going to be minus always. So, you need not even think, it is going to be minus 10 in the formula. So, you can use that plus sign as it is. For the time being, we will just keep it like that. Suppose focal length is given. For a concave mirror, the focus lies here, isn't it? So, how are you going to find the focal length? From here you will measure, like this it will be measured, isn't it? Say that is say 7 centimeters. So, focal length will be written as minus 7, because again it is coming from here to here. So, for concave mirror, U is negative, F is also negative. So, F is negative with a minus sign, U is also negative for concave mirror. In which case, what happens to the convex mirror? For a convex mirror, your focal length is on this side, whether the, in fact, you can take it as this way, your focal length is on that side, whereas the object is always on the left side. So, your U is negative, but F is equal to positive. So, for a mirror, if the name of the mirror is given, the type of the mirror is given, then for convex mirror, immediately focal length is given as 10 centimeter, put it as plus 10. Focal length is given as 25 centimeter, put it as plus 25. So, you can put here as directly with the sign, whereas u is going to be negative for both the mirrors, because always u is kept on this side. The mirror is there, u is kept on this side, the object is kept on this side. So, these distances are always negative. So, u is going to be, whenever object distance is given, you do not even have to think twice, whatever that number is there, put it as minus. If so, this will be minus, this will be minus for concave mirror, this is minus and that is plus for convex mirror. So, these two things we already know. We accordingly we will decide whether what we got V with a sign, does it relate correctly with the ray diagram.